Today we're going to talk about integrals as this word, antiderivatives. Okay, so do you remember what a derivative was? Yeah. It's the slope of something. And remember the process to take a derivative of a function. Well, if you undo a derivative, it turns out it's the same process as taking an integral. So today we're going to look at integrals as antiderivatives, and we're going to tie it to the fact that it's area. Okay, so let's first talk about order of integration. When you have a definite integral, and by the way, the word definite integral means that when you have this integral symbol, you have a number here and a number there. So it starts somewhere and ends somewhere. Okay? Now, the order of integration is from b to a, f of x dx. All right? If you change those to a to b, right, then you have to put a negative out front. The way we usually do it, so suppose you have 3 to 0 x squared dx. What this is telling you is find the area under x squared from what to what? From x equals 3 to x equals 0. That's sort of like reverse direction, right? Well, we always have to put this in the correct order and change it to 0 to 3 and put a negative out front. X squared dx. Okay? So remember that the bigger number always goes on top. So it would go from -2 to 0 or 0 to 3. Okay? All right. Take a look at what this is saying. This is saying find the area under f of x from a to a. How much area is there from a to a? None. So that's why that area is always 0. So it doesn't matter. So, if you have a function like this and, you just want, like, you want the area on that little point, that's not even a thing. That's just a point. It has no dimension. So it has no area. Okay, so for example, if you have 2 to 2 sine of x dx, it doesn't matter what you have in the integrand. That's just 0. Okay? All right. Now take a look at this one. You have k times f of x. So again, we're looking for area under a curve. So imagine, it was a real life example. Imagine I needed to put carpet in this room, okay? And I want to know the area of the floor so I could buy carpet accordingly, right? Now, if I had 5 identical rooms, how much would the area increase? How many times more area? Like how many? By 5, right? So if I needed to find the area of, and I'm just multiplying it by k, I could just take the k out, find the area, and multiply it by that number. So if I had 4x squared dx from 0 to 2, I could just rewrite that as 4 times 0 to 2 x squared dx and just do my process that way. Sum and difference. Okay? So again, if I had to find the area of f of x plus g of x, so 2 rooms, okay, I want to find the total area of how much rug I need. Well, I don't have to, calculate them together. I could do one room separately and another room separately. So you could separate those. What does that mean for polynomials? If I have to find the area from -2 to 2 of x squared plus 4 dx, I could separate that down the middle. And I could say -2 to 2 x squared dx plus -2 to 2 4 dx. So you see how the x squared plus 4 gets separated? Okay, this next one, you've already been doing it when we had those diagrams and you had to find the area underneath. So look at what it says here. If you have an integral from a to b and then another integral from b to c, okay, well, that's just the same as going from a to c. Okay, so if I had the integral 0 to 5 f of x dx plus, I don't know, 5 to 8 f of x dx. So the thing is, though, that inside it's the same. Well, that could just be 0 to 8 f of x dx. Okay?
So if we were doing like f of x, the insides have to be the same.
Yeah. Uh-huh. Okay, so take a look at these. These are my favorite. I love these. These are so much fun. F of x. I hate that these parentheses go away. Okay. All right. So look at what I have here. I have negative 1 to 1 f of x is this number. 1 to 4 f of x is this. Negative 1 to 1 h of x. And negative 1 to 5 h of x. I have to put them together in pieces like a puzzle in order to find what I'm asked for. So here I'm asked from 4 to 1. Well, what's wrong with this notation, 4 to 1? It has to flip over, right? So this is the same as negative 1 to 4 f of x dx. All right? So this is equal to negative, and what is 1 to 4 f of x dx? Negative 2. So that's just 2. You see how fun it is? That's so cool. So look at this one. Negative 1 to 4 f of x dx. Well, look, I could just split that up. Oh, sure. Yeah. So I could split this up from negative 1 to 1 and from 1 to 4. Right? Because if you're going from negative 1 to 4, you could do it in 2 steps. And so negative 1 to 1 is 5. 1 to 4 is negative 2. So together, that's 3. Right? So it's just like when you were doing like these things, except now you have the symbols. Okay. All right, so here I have negative 1 to 1 f plus h. Well, I could split it up like this. Negative 1 to 1 f of x plus negative 1 to 1 h of x. Right? And what's negative 1 to 1 f of x? 5 plus 7, 12. No units, nothing, just that. Okay, what about 0 to 1? F of x. Well, I have negative 1 to 1 f of x. Okay, so it's half of the... Oh, wait. Okay, so I have negative 1 to 1, right? I know how much that area is. But now I want 0 to 1. So the suggestion is you can take half of it. Okay, so you could take half of it if the function looks like this and if it's symmetric on either side. But what if it's not? What if it's like some weird function like that, where splitting it into half is not necessarily half of the area, right? Well, we don't know. So here, there is not enough information. That's a trick one. Okay. Ooh, this is my favorite one. 1 to 5 h of x dx. All right, 1 to 5 h of x dx. Okay, I don't have that. I do have negative 1 to 5. And then I have negative 1 to 1. Let's just draw that. So I have negative 1 to 1 is 7. And then I have negative 1 to 5. So I have negative 1 to 5. Let me do it in a different color. The area here is how much? 12. And then I have negative 1 to 1, and that's 7. What I need is 1 to 5. So how much is that? 5. Is it 5? Yeah, 5. Okay? So the way we do it, the way we write it is 1 to 5 h of x dx is equal to negative 1 to 5 h of x dx minus negative 1 to 1 h of x dx. Thank you. Right? So to find this little bit, you have to subtract blue minus green, and you have to write it that way. So that's 12 minus 7, 5. Bye. Okay, what about here? Ooh. It's okay, I'll do it later. Yeah, thank you. Okay, what about this one? Let's split this up. Okay, we're splitting it up this way. So 3f of x minus h of x. And now look, the 3 here can come out. So 3 times negative 1 to 1 f of x dx minus negative 1 to 1 h of x dx. Okay, so this is 3 times, how much is this? 5 minus 7, that's just 8. Okay, one thing before you turn the page. Notice, every single time when I've got this symbol, I have also got a dx. Those two cannot exist without each other. It can never just be f of x. I don't know what that is. Okay, you can't do that. All right, it's got to have the dx because it's these two that come together. Like these two are the ones. It's like a symbol. It's like a set symbol. All right, it's a, what do you call it? What am I trying to say? It's like an image, right? Like on Word, like you can't separate it. It's one entity, one image. You can't break them down. Okay? All right. So now the book does all this stuff, and then right when they should teach you this here, they don't, and then they teach it to you a chapter at, like later in the next chapter. That's just silly. So we're gonna bring it back here, okay? Because they, like, you start using integrals and then they don't tell you what they are until later. Whatever. We're gonna do it now. Okay. So we've been talking about integrals. Now let's talk about what an indefinite integral is. Okay? All right. The family of all antiderivatives of a function is the indefinite integral. Okay? And it's denoted by this. Okay, so for example, suppose you had y equals x squared, right? Or x cubed. What's y prime? 3x squared. Now, if I were to give you this and said, okay, now undo what you just did, what would you do? How did you get here? You subtracted the exponent, so you would have to add to the exponent, and then you would have to figure out some way to get rid of this again, right? So when you undo this process in order to go from here back to the top step, that's called taking an antiderivative. And that's the same as an indefinite integral. Okay? Okay? Question? That's a 3. It was a square, then I changed it to a 3. I started with a 2, but to make it more interesting, I changed it to a 3. Okay? So now, if f is a function such that if the derivative of capital F is f of x, then the integral is capital F plus c, where c is an arbitrary constant, blah, blah, blah. Okay? So now, here's what I mean by this. Suppose I give you y prime equals 3x squared. Okay? And I tell you, come up with a function that has this as a y prime. Okay? So come up with a function. Somebody come up with a function that has 3x squared as its derivative. Okay, x cubed, right? Okay. What if I said x cubed minus 7? It's still the same derivative, isn't it? What if I said x cubed plus 154? Same. How many possibilities are there? Infinite. So really, if you want to just say all the answers together, you would just say x cubed plus some constant c. Okay? That's an antiderivative. So you get f of x plus c. Okay, so properties of definite integrals. Here are some rules now. So the top 2 rows are more of what we just talked about. So notice, what's the difference here from what we were doing before? It doesn't have the like A to B, right? It doesn't have numbers here. So even if it doesn't have numbers, it's still the same rules that apply. Okay? Now, let's talk about some power formulas. Let's see how really you go back and forth here. All right, so let's talk about power formulas. If you have the integral u to the n du, so now you have to take the antiderivative. Here's what you do. U to the n plus 1. So you add 1 to the exponent. And then whatever you get, you divide it by the exponent, the new exponent, plus c. Okay? So let's talk about this for a minute. Suppose f of x is equal to x to the 6. What's the derivative? 6x to the 5. Now, if I had 6x to the 5 and I wanted to get back x to the 6, what would I do? I would add 1 to this. What would I get now? 6x to the 6, but then divide by the new exponent, and what do I get back? X to the 6. Okay? So we have to go backwards. Remember how when you took a derivative, you subtracted 1 from the exponent? Now you add 1, but divide it with it. Plus c later on, yeah. Okay? Okay, now here's the one difference though. If you have u to the minus 1, just minus 1, not minus 2, minus 3, minus 4, just minus 1, then it's written as 1 over u du. Is that right? Its derivative, its antiderivative is ln of u plus c. You have to remember that. Okay, so how did we get this? What's the derivative of ln of u? 1 over u. What's 1 over u? U to the minus 1. Okay, so you're going backwards now. Okay, so if you have u to the minus 2, do you do 1 over ln squared? No. Oh my god, no. Okay, that's different. Okay, trig formulas. Okay, let's do it this way. What's the derivative of sine? Cosine. So integral of cosine is sine. Okay, it's kind of like reverse that. Everything is reversed. What's the integral of cosine? What's the derivative of cosine? Negative sine. So the integral of sine has to be negative cosine. Okay? You just have to think, how do I go backwards? So now, as promised, this chapter will throw you for a loop. Okay. Now, So those are the trig formulas. Exponential and logarithmic formulas. What's the derivative of e to the x? E to the x. So look at that. The integral of e to the u is also e to the u plus c. Okay, that's an easy one. We will focus more on this. I'll do some more of this tomorrow. Next week. Okay. This is the one. This is the one. ln of u du is u ln of u minus u. Don't ask questions, just accept it, move on. This is one where we don't ask questions. Okay? ln of u is u ln of u minus u. So if you had ln of x dx, it's just x ln of x minus x. No questions asked, plus c. Eli, you had a question.
Yeah.
Okay, let's just practice. All this got us excited. Let's do some practice. Okay, we're going to start with the basic one. Okay? All right. So, just a power one. Okay? This is called, okay, so this is the power formula. All right? We just have to go backwards. So what you do is x to the power of 2 plus 1. So remember we were subtracting exponents, 1 from the exponent. You add, and then you divide by the new exponent, 3 plus c. And that's x cubed over 3 plus c. What happens if you forget the plus c? Points off, definitely. Like, that's it. Points off. Huh? You just leave it like that. That's it. That's the answer. X cubed over 3 plus c. Now, if you're not convinced, which I'm not right now, let's take a derivative of the answer. What's going to happen here? 3 comes down, cancels with this, so I get x squared. What's the derivative of the constant? 0, so you get x squared back. Oh my God. When you undo what you've done, you have to get the same thing back. It's an antiderivative. Okay. This one, the 2 can just be pulled out front, so we're not going to care too much about it. I just transfer it over. Now, what's the antiderivative of cosine? Negative sign, you say, huh? Just sine of x plus c. Suppose you don't trust yourself. Now go back. What's the derivative of this? 2 cosine x. You see that? It's counterintuitive at first. Then you just learn that it's not gonna. You'll learn. Okay. What's the integral here? E to the x dx? Just plus c. Huh? You don't. Okay. Very good question. And you know what? Thank you for reminding me. Okay. This and this together, okay, is telling you take the antiderivative of 2 cosine x. Once you find the antiderivative, you don't write it anymore. You see what I mean? Like, it goes away. This was telling you to convert this to 2 sine x, which now you've done, so you don't need the operation anymore. Lots of times students will put that integral sign back here. That doesn't make sense. You know what that's like? That's like having this. What's the purpose of the plus sign? To combine the 2 and the 5, right? Well, it's like if somebody said 7 and then put the plus back in here. Like, you don't need the plus anymore. You already did the operation. Okay? So same thing here. Once you did the operation, the integral and the dx go away. They come together and they leave together. Don't do this bit either. I don't know what that is. Okay? They enter together and they exit together. Okay, I'm yelling again because I'm so excited. Okay. Let's go back to this one. Okay, now look. 1, 2, 3, 4 distinct terms. If you were to take a derivative of this, you would do each one separately, independently of one another, right? Same thing here. That's what we're going to do. So we're going to do 2x to the power of what? 4, good, over 4 minus the new, yeah, you divide by the new exponent. Okay, let's do it again. 3x to the power of 3 over 3 plus 8x to the power of 2 over, okay, plus 4, huh?
4x.
4x. Why 4x? Because here there is an x to the 0. So here you put an x to the 1 over 1. Obviously, you're not going to write the 1s in real life. Plus c. Okay? So do we simplify? Of course we do. What happens if you don't? Points off. Okay? There you have it. Okay, now, if you don't believe me, take the derivative of this, and you should just get that back. All right? So this one, the 4 will come down. It'll be 2x cubed minus 3x squared minus 8x plus 4. Ah, plus. Thank you. See, you shouldn't have believed me. Okay. Here. Again, we're going to do these separately. Okay? Once you have this here and the dx here, it means, it applies to all of these. You don't really need parentheses. You can put parentheses, but you don't need them. Okay? So we're going to do this separately. What are we going to get? 3e to the x plus, here, it's going to be 2x to the 5th over 5 plus c. Okay? See how simple? Okay? Yeah.
So we don't pull the 3 out there?
You don't have to. Yeah.
It wouldn't make a difference.
Right. Okay. Square roots. Okay, if these are all about powers, then let's write this as a power. Like this. Okay? So now, the first one, it'll be 6x squared over 2 minus x to the 3 over 2, over what? Divided by 3 over 2. This is where we get into trouble sometimes. We're going to go slow. So, yeah, you do plus 1. Okay. And then plus c. Now, here we're going to get a 3x squared, minus, what's this? Okay, so if you divide by a fraction, that's the same as multiplying by the reciprocal. So this is just minus 2/3 x to the 3 over 2 plus c. Okay? Divide by 3 over 2, multiply by 2 over 3.
For these fractions, if it's easier when we're doing like on a test, can we put them into decimals and then do it? No.
Always want fractions. Okay. Okay, so here's one. What about this one? Is it an ln?
No.
No, because it's not minus 1. Same thing as a power rule. So we're going to add 1. So it's going to be x to the negative 1 over the new exponent, negative 1, plus c. Okay? Now, is this the same as negative x to the minus 1 plus c? Yeah, right? But we can't have a negative exponent, can we? So this is negative 1 over x plus c. Eventually, we're going to be able to go from here directly to this, like that. Okay? 2 things in 1. Okay. Negative sine of x dx. Positive cosine or negative cosine when all is said and done? Okay, so it's either or. Okay. What's the antiderivative of just sine? Negative cosine. Negative sine then will be positive cosine of x dx. Okay, sines and cosines, it's always confusing with the negative. Okay, so now it's the test. And I'm like 95% sure it's cosine, but I don't know. What do I do to figure it out?
Go back.
Go backwards. What's the derivative of cosine? Negative sine.
Wouldn't you not have the dx in there?
Ah, what? It's plus c. Oh my gosh. I must be getting hungry. Yeah. Guys? Okay. So e to the x is just going to give us e to the x again. Kind of boring. I have a really amazing joke with that, but for a later time. Okay. What's going to happen here? Plus what? I need to add 1, right? So it's going to be negative 2/3 plus 1. How much is that? 1/3. So it's going to be x to the 1/3 over 1/3 plus c. So this is e to the x plus what? 3x to the 1/3 plus c. Okay. What am I going to do for the next one? 4x to the half dx. Okay, now if you want to put the 4 out here, you can, makes no difference. It's the same. Just know that it's going to get carried over here. So 4 x to the power of how much? 3 over 2 over 3 over 2 plus c. This is equal to 2/3 times 4 times x to the 3 over 2. So finally, 8 over 3, x to the 3 over 2 plus c. Right? How awesome is this? Okay, but we could do it in one day. Okay. 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 So look. If you have, look at this. If you have this, right? You integrate something. And then you take a derivative, right? So if you integrate and then take a derivative, what happens? You undo one, like one undoes the other, right? So if you integrate and then take a derivative, you get the same function back, okay? So that means if one undoes the other, that means one is the opposite of the other. So the integral is the antiderivative of f. We just talked about this, okay? So now, if f is an antiderivative, the integral, the antiderivative, then if I take the integral, the antiderivative of little f, I get big F of x, okay? Now, that's going from a to some number x. Now, following that process, if this integral symbol means antiderivative, then if I take an antiderivative of little f and I get capital F, but if it's going from a to a, what should all that equal to? 0. So the antiderivative f of a plus c must equal 0. That means, what is c? It's negative f of a. Okay? So now, take a look here. If you have f of t dt, okay? Remember how from a to x, we said you get capital F plus c, right? You take an antiderivative, you get something plus c. But we just said, what is that c equal to? It's negative f of a. So if you put it all together, then the antiderivative is just f of x minus f of a. What does all this mean? We just learned how to take the antiderivative. We just learned how to find the indefinite integral. But now what if you had limits on the top and bottom? What if you added an a to x? What happens then? Well, here's what happens then. So it says here, use the formula, blah, 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 to figure this out. So basically what you're going to do here is this. You're going to evaluate the antiderivative at b and at a. So here's what happens. All of a sudden now we have a derivative, but it's we have an integral, but it's a definite integral. You have a 0 and a pi here. First step, you ignore those numbers, those constants, and you just take the integral of sine of x. What was the antiderivative of the sine? Positive, negative cosine of x, sorry. Now, if it goes from one number to another number, then we're going to add a step. Brackets, 0 to pi. This is just notation now. Then the formula says, put the top number into the equation minus the bottom number into the equation. So we're going to do negative cosine pi minus negative cosine 0. And here's where like this comes up again, the sines and cosines. Cosine of pi is -1, negative 1 is +1, minus, that's just -1, so together, that's 2. Okay, what the heck have we done? What have I found? What have I done? Well, here's what I've done. Sine of x looks like this, right? From 0 to 2 pi. I've just found the area underneath from 0 to pi. That's what I've done. Okay, so let's do another one. Here, 3x squared. All right, I'm just going to take a derivative, an antiderivative. It'll be 3x cubed over 3. But we're going to go from -1 to 2.
We leave out the plus c stuff.
Yes. Once you have a definite integral, the plus c becomes the f of a. Yeah, good. Yeah. So that's going to be x cubed from -1 to 2. And that's going to be 2 cubed minus -1 cubed. That's 8 plus 1 equals 9. Okay, again, what have I found? It was 3x squared. That's a parabola. And I found the area from -1 to 2. So that shaded area. Okay? We're not doing trapezoids anymore. We're not doing rectangles anymore. This is doing RRAM, LRAM, trapezoid in one shot, and this is the answer. No longer an approximation. This is it. We're there. Okay? This is the exact answer. Okay, here. All right, what's going to happen here? It's going to be negative x to the -1 over -1. Okay, now look. This is all fine and cool. The bracket thing, there's another notation, guys. You just do a vertical bar, and you go 1 to 2. I know, so many notations. Okay.
Wait, why don't we do brackets?
Both are acceptable. I like this better because it's more concise. It's quicker. You just boom, 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 you go. This becomes, okay, negative goes away. X to the -1 is 1 over x, still from 1 to 2. So this is 1 over 2 minus 1 over 1, that's a negative half. The important thing is the top goes first. Otherwise, your integral is reversed and you get a negative answer. Okay, what's the integral of secant squared these days? Tangent x. It's cosecant, cotangent, secant, tangent. The cos go together. From 0 to pi over 4, thank goodness, tangent and pi over 4 go really well together. So that's tangent of pi over 4 minus tangent of 0, 1. Because it's 1 minus 0. Okay, one last thing. Wait, I want to do this. Ah, darn it. Okay, I want to do this too. I'm not going to do mean value theorem. I'm just going to, okay. Average value. I'm not going to do it. I feel bad for the